Welcome to this class. We are going to look at area part of a circle. Area part of a circle. That is going to be our topic today. Area part of a circle. I hope everyone can see my board. Area part of a circle. So that is our topic today. And we're going to start with the area of a sector. The area of a sector. So we remember that our area of a sector, we were giving the formula theta over 360 degrees pi r squared. That is the formula we were using to find the area of a sector. That is just a reminder. We can look at this one example on how to do that. Example 1, find the area of a sector. Area of a sector. I think someone wants to join the class. So find the area of a sector. Let me allow someone to so find the area of the sector. Area of the sector of a circle. The circle of radius 3 centimeters. If the angle subtended at the center is 140 degrees, you can take pi to be equal to 22 over 7. So this one, we simply apply the formula directly. The solution for this, the area is given by theta over 360 degrees pi r squared. So we substitute theta is 140 degrees divided by 360 times 22 over 7 times our radius of our circle is 3, so it's 3 squared. So you get your answer to be 11 square centimeters. So that is so direct. So let us look at question 2 on the same area of a sector. And the question reads, the area the area of a sector, of a circle, radius, with the radius 63 centimeters is 4158 square centimeters. So this one we are given the area and they're asking you to calculate the angle subtended at the center of the circle. So you have to find theta. Then you can take pi to be 22/7. So that is our question number 2. So we can solve the solution. Now solution, the area we already given, area which is theta over 360 pi r squared. Area we are given to be 4158, which is equal to theta, which we are not given, divided by 360 times 22/7 times r squared. Our radius is 63 squared. So when you work, so theta is going to be now 4158 times 360, that is times 7 divided by 22 times 63 times 63, and with that our theta is going to be 120 degrees. So that is how we find our theta, angle theta. So that is area of a sector. You can look at the area of a segment. Area of a segment. Area of a segment. Area of a segment. Now, under the area of a segment, we are going to encounter, we can look at this circle with the center O. This is the center O. This is radius, and then that shaded part. This is H. We have theta somewhere there. So this is A, B. Now, the shaded part is what we call the segment. This is what we call the segment. And to find the area of this segment, area of the segment is given by theta over 360. That is the area of the minor sector minus the area of the triangle. So the minor sector, its area is given by theta over 360 pi r squared minus the area of the triangle, which is a half base height. Or we can take a half into that is a half AB sin theta. depending with the values given. So that is how you're going to find your area of that segment. So we can look at example 1 or 2. Move to the next thing. So example, the figure below is a circle the figure below is a circle with center O, and radius 5 centimeters. If ON is equal to 3 centimeters, AB is equal to 8 centimeters, and angle AOB is equal to 106.3 degrees, saying find the area of the shaded region. So the figure that I'm going to draw is a circle with center O and radius 5 centimeters. Now if ON is equal to 3 centimeters, AB 8 centimeters, and angle AOB 106.3 degrees, find the area of the shaded region. Now this is the region on the circle. This is my circle. This is the center O. Then you have this. So the whole of this is 8 centimeters. Then you have A, B. Then we have 5 centimeters as our radius. Then we have this one. We have point N there. The middle of that line, it's point N. Then this is now the shaded part. This is the shaded part. That is the shaded region. So find the area of the shaded region. In other terms, they're asking you to find the area of the segment. The area of the segment. Now, let me admit this one. Okay, welcome Benedict. Though you are very late for our class, 30 minutes late. So we are proceeding. So now the area of this segment, we said you take the area of the sector minus the area of the triangle. Now, area of the sector here, area of the sector, so area of segment is equal to area of sector minus area of triangle. Area of sector is given by theta over 360 pi r squared. Then we minus area of the triangle, which is now simply half base height. Half base height. Remember, we were given ON to be 3 centimeters in our question. 3 centimeters. That means that is the height. Now we substitute theta. Theta we were also given in the question, whereby we were given angle AOB, this one, to be equal to 106.3. We are also given the question degrees. So theta is 106.3 divided by 360 degrees times, we can use 22 over 7 or 3.142 times radius, which is 5 squared. Now minus a half, base is 8 and the height is 3. That one. So when you work this one in brackets, you are going to get 23.19 minus 12. So you will arrive at 11.19 square centimeters. So that is the way you arrive at the area of that shaded region as shown. So that is one example. We can move to another example. Example 2. Example 2. A chord XY of length 12 centimeters. Is drawn. In a circle. With center O. And radius 10 centimeters as shown below. So this is how it looks like. So we have this. Now this is 12 centimeters, the whole of it. Now the whole of this 12 centimeters. Then radius 10 centimeters. Then we have this is point X, this is point Y. Then center O here. So this is point M. It bisects the line XY at point M. So the shaded, this is now the shaded part. That is the shaded part. Now the question is calculate the area of the shaded segment. Calculate the area of the shaded segment. Now we use the same approach that we've used on example 1, whereby we're going to find the area of the segment, the area of the sector minus the area of the triangle. For us to do to deal with this one, the area of to have the area of the sector, we must look for angle x or y. This angle, you have to look for angle x or y. For us to get that angle, we take one of the triangles, one of these two right angles triangles, this one. From here to here is 12, therefore from here to here is 6 centimeters. Then ON we are not given, but we are given what? The radius, which is 10 centimeters, that acts as our hypotenuse. Then we look for this angle theta, so that whatever we are going to get, we are going to multiply by 2 to give us the angle x or y. So having that, we can say that sine, using the trigonometric ratios, we are saying sine theta will be equal to opposite. The opposite for theta is 6 over hypotenuse, which is 10. So you get 0.6. So theta will be equal to sine inverse of 0.6, and our theta becomes 36.8699. Now remember, you have to multiply by 2 for it to give us the exact angle, which is angle x or y. So you multiply by 2, you get 73.7398 degrees. So now this is the angle that we are looking for. So we go and find the area of the segment. Area of the segment. Area of the segment. And on this, the area of the segment, we are going to find area of sector over sector minus area of triangle. Area of the sector, the formula remains theta over 360 pi r squared minus area of the triangle, which is a half. Now that we don't have the height and we have the angle, we can use a half a b sine theta. So that one becomes a half AB sin theta. Then we continue. So we substitute theta. Our theta is 73. So that one becomes to 73.7398 over 360. Then times theta. You can use 3.142 times radius squared, which is 10 squared, then minus the whole of this, minus a half AB, so A is 10, B is 10, then sine theta. So our theta is 73.7, 73.7398. That way. So when you work out this, you're going to get 64.3584 minus 48. So that when you minus or you subtract 48 from 64.3584, you're going to remain with 16.3584 square centimeters. So that is how you arrive at your final answer, which is the area of the segment or the shaded region in that diagram. So it is that simple and clear, as you can see. That simple and clear as you can see on your screen. Are we together up to there? Are we together? Can I confirm if we are together, please? Good, Benedict. I can see Benedict is Anne, also fine. Benedict and Anne. Where is Damaris? Okay, I can see Anne. Anne is asking, what about when we use, is it the zero? The zero in 4 significant figures. Which question is that? Can you come up, Anne, please? You can unmute your mic. Ndio nikuelewe.
Teacher, ni vita sio zero.
Ni?
Vita.
Oh, it's theta. Theta in 4 significant figures. It's fine. We can use it in that 4 significant figures. There is no problem.
Thank you.
Welcome. So I want to see response from I've seen Anne, Benedict. I want Ruben and Damaris, please. You can respond. Ruben and Damaris, so that they confirm if you are together or you are left behind. Okay, Damaris is fine. So Ruben, please. Okay, Ruben is also there. So I can continue. So we are moving to the next part, which contains some good marks. Usually some 10 good marks in section B. Still on area part of a circle. This is what we call the area of intersecting circles. The area of intersecting circles. Area of intersecting circles. I'm very sure you've been across some questions on intersecting circles, which normally carry a lot of marks. That is 10 marks section B. Some of you find it easy, others find it difficult. So today we are going to, let's take our time, look at the same. So we're going to look at one example for today. Then we shall look at more examples in our next lesson. I want us to see how we are going to connect with the area of sector, area of the triangle, then area of the segment, the one we've finished looking at. So we can look at this example, one example. In the figure below, chord AB is equal to 9 centimeters. Calculate calculate the area of the shaded region. So in the figure below, chord AB is 9 centimeters. Now calculate the area of the shaded region. So I'll draw this one. So as I'm drawing, kindly remember those ones who were not there on Saturday. Our class was recorded, YouTube. You can go there, check out. It was on indices. Kindly find time and watch that class. It will help you somewhere. So this is the diagram. You can see the way they are intersecting. So this is O1, this is O2, this is A, then this is B. So this is 8 centimeters, then this is 6 centimeters. The other radius 2 is 6 centimeters. Then we are told that AB is 9 centimeters. Then this point is point M. Point M. Now, the shaded region, this is the shaded region. So this is the shaded region. So the diagram is as you can see. Remember, we are given AB to be 9 centimeters. Don't forget that. You can show that in diagram if possible and indicate 9 centimeters. 9 centimeters, like that. Then we now focus on the solution for this question now. Now this intersecting chord, we can bring it out and see how it looks like. Looking now at solution. This is how it looks like. There are two. These are two segments, so which are they are combined. Two segments that are combined. This is how it looks like. A sketch, just a sketch of how it looks like. This one having 8 centimeters, and then still this is 8 centimeters, and then this line to point M, and then we have another one. And this one, this another one. You can see the shaded is a segment. Still have point M, and this is A, B, A, B. So they share line the common chord AB, which is 9 centimeters long. So these are the two what? This is how it looks like when you separate. This is how it looks like, the two now. So this other side we have 6 centimeters, this 6 centimeters, 6 centimeters, and then 9 centimeters, the whole of it. And the whole of AB is 9 centimeters. This is O2, 0.01 now. Now having that, you can, and getting to know that the shaded region is just a combination of two segments, then you can find the area of the first segment and you add to the area of the second segment. That is how you arrive at the area of the shaded region. So we can now focus on the first one using this OA to find the shaded region. So we can now extract this one of these right angled triangles in this triangle O1 AB, which is shown as these. We are not given the angles, so we are going to look for that. Now the whole of AB is 9 centimeters, half of it is 4.5, then 8 remains, the radius remains, which is going to act as our hypotenuse. This is O1, this is M, this is A. Now we need to find this angle theta, so that when we multiply by 2, we find the size of angle AO1B. So we find this theta and then multiply by 2, we find that angle, so that it helps us to find the area of the sector and the area of the triangle. So theta, to find theta, you have to say sine theta is equal to opposite. The opposite is 4.5 divided by the hypotenuse, which is 8. There you get 0.5625. Now to get theta, our theta now becomes sine inverse of 0.5625. Sine inverse of 0.56, and our theta becomes the sine inverse of 0.5625. From your calculator, you're going to get 34.23, and then you multiply by 2 to get the size of the whole angle AO1 then B. So when you multiply by 2, your final angle becomes 68.46 degrees. So that is now the size of the whole angle. This one becomes 68.46 degrees. So we are done with finding the angle for that side. Now we look for this other angle. Some questions, they are normally separated. They ask you to find the angles, the two angles. So the first angle, you have so that one you are always asked to find the size of the angle, so you get that angle. Then you find the size of the other angle, AO2B. So using this the figure now, the second one, then we extract this right angled triangle inside. We shall have half of that 9 is 4.5. Our hypotenuse now changes to 6. Now this one will be now our new theta, so that whatever you're going to get, to multiply by 2. Now to find sine theta will be equal to opposite, which is 4.5, over the hypotenuse, which is 6. So 4.5 divided by 6, you get 0.75. Then for you to get theta, now theta becomes the sine inverse of 0.75, which gives us 48.59. Now we multiply by 2 to get the size of the whole angle. So we get 97.18 degrees. 97.18 degrees. So this is now the size of the other angle. This is angle AO2B. So that is the size of that angle. And here is where we got the size of angle AO1B. So we have the two angles. Now we can find the area of the shaded region by getting the area of each segment separately. Then we add them together to get our final answer. So let's start with the AO1B. So the area of the segment, area of segment is equal to, now the area of sector minus area of triangle. We know the formulas. Area of the sector is theta over 360 pi r squared minus area of the triangle. We shall use a half now that we have the angle AB sine theta. Half AB sine theta. So that our theta for A, we are starting with AO1B. So our theta now here is going to be 68. So we have 68.46 divided by 360 times pi. You can use 22 over 7 r squared, the radius. The radius here is 8, so 8 squared. Now 8 squared, we minus a half AB. Our A is 8, our B is 8, then sine theta is 68.46. You now, using a calculator, you work them out separately and keenly, so that because any mistake here, the remaining part of your answer becomes wrong. So when you work this in brackets, you're going to get the area of the sector to be 38.24 minus, now the area of the triangle becomes 29.76. so that when you minus 29.76 from 38.24, you remain with 8.48 square centimeters. So this is now the area of the first segment. So we have to take the area of the first segment, add to the area of the second segment. So we now go to the area of the second segment, whereby the area of segment 2, which is still given by the same formula, area of sector minus area of triangle. Formula remains theta over 360 pi r squared minus a half AB sine theta. Now we substitute our theta now for the second one changes to 97.18 over 360 times 22/7 times r squared, our radius squared, which is now our radius also changes to 6 squared. Then we minus the area of a triangle, which is a half, times a. Our a changes to 6, b also 6, then sine 97.18. that way. Now we subtract the answer. So here you're going to get 30.53 minus 17.86 from your calculators. That is what you're going to get. Then when you subtract, you're going to remain with 12.67 square centimeters. So this is now the area of the segment 2. The question was asking the area of the shaded region, the area of the whole shaded region, which is this one, and there are 2 segments, and we have the area of the 2 segments, so we simply add the 2. So area of shaded region is equal to area of segments. So we add the 2 segments, 8.48 48 square centimeters plus this one 12.67 square centimeters. So you'll arrive at 21.15 square centimeters. So that is now the area of the shaded region. Which becomes 21.15, as you can see. Do we have any question on that? Any question on that, on how to find the area of intersecting circles? Any question? Any question? Any question? intersection. And are you getting? Good, Anne is fine. Benedict. Good, Benedict. Damaris. Yeah, it's fine. Then we have Ruben. Okay, good. So with that, there being no question or concern, or is there any question or any concern? Any? Is there any? Okay, no question. So we shall continue from there tomorrow. We shall look at more examples on the same, then look at something else, give exercise, then conclude on the same. Okay, we can leave the group now. Thank you for your time.